Hello and welcome to my presentation on matching job ads to job seekers' needs for flexible working. My name is Jean-François. I am assistant professor at ICN Business School in France, and most of my research is about the impact of technology on employees. So I've used person environment fit theories before, and this project is a bit different. You will see why. That's because it starts from an industry problem, which is about designing an algorithm that will use person environment fit theories to suggest job ads to job seekers based on some of their needs. So this project started from an industry problem. A certain company learned about my research on person environment fit and thought it could be applied to a problem they were facing. So this company is called FlagJob. It is an internet job board providing job ads to job seekers, I would say in a niche market. So this niche market is flexible working. So in this website, job seekers can find job ads which contain a certain level of flexible working arrangements. Okay, so I give below three dimensions of flexible working that are used in the website and that correspond as well to the academic research on flexible working. So the first dimension is flexible working in terms of time. So this is when individuals can work whenever they please, with no fixed schedule, part-time arrangement, etc. The second one is place. So when individuals can work wherever they want, with arrangements such as teleworking, co-working, etc. And the third one is content, when individuals can work however they want, with freelancing or the choice in communication media, etc. So this website, FlexJob, is regrouping certain job ads containing some sort of flexibility. And the job seekers that go to these websites are looking for jobs that would provide them flexibility. Now, the company need was to develop an algorithm able to predict if a certain job ad will correspond to the needs in terms of flexibility of job seekers. Okay, so job seekers go to this website, they see a list of job ads, and what the company wanted to do is to give them an idea of the extent to which each job ad match their needs for flexible working before the individuals even have to read these ads. Okay, so that's the important part. Uh, we want to predict the extent to which a job ad will fit the individual needs before the individual has to read this job ad. So it is, I would say, a prediction of perceived fit. So as such, it is highly relevant to a person environment fit research, which is why I accepted to do this, I would say, action research project, because it would be about predicting perceived fit based on individuals' needs for flexible working. Now, from a research perspective, this has several obstacles, I would say. So the first obstacle is the lack of research on the antecedents of personal environment fit. So we know about some of the consequences of personal environment fit. We know about some of the process, although not fully. But we know very few about the antecedents of perceived fits. And there are some debates as well about distinction between perceived fits, actual fit, etc. So this paper from Edwards and colleagues 2006 is presenting some of these challenges. So if we don't know about the antecedents of fits, it might make it harder to predict perceived fits because we don't know about some of its antecedents, especially in the context of flexible working, because fit for flexible working needs has not been studied so far. The second obstacle is that person environment fits traditionally measure fits as with direct measures. So either direct measures of fit as perceived by individuals. So this is what is called a Demoller approach by Edwards and colleagues. So in the context of this project, it would be like asking job seekers to read a job ad and then estimate if this job ad is corresponding to their needs in terms of flexibility. Now, this is not possible from an algorithm perspective because we want to predict fit without individuals having to read the job ad. So we cannot ask them directly about fit. The second way of measuring fit is to directly measure both supplies and needs. So in the context of this project, it would be like asking job seekers to state the flexibility they need in terms of time, place, content on one end, and on the other end, ask them to read the job ad and estimate the extent to which this job ad seems to provide flexibility. Now, this is impossible as well because, again, we want to predict fit before individuals have to read the job ad. So we cannot ask them any direct measures that are directly related to a job ad. We can still ask about their needs and their preferences because that can be done before, but we cannot ask them questions related to specific job ads. So this is the first problem. Now, these problems have been answered in two ways, I would say. One way is the industry answers to this problem. Traditionally, it lies in big data. So companies might decide to collect vast amount of data, then throw everything in an algorithm, and the algorithm will do the predictions quite well. So this would be the equivalent in linear regressions of inputting all the variables we have in a project in a linear regression for the sole purpose of improving the R-squared prediction. So we know from a research perspective, this is not really acceptable, okay? Because we don't want to collect useless data and then throw everything just to increase the predictive power. No, we want parsimony and we want a theory drive. So the second answer to this problem, which I suggest, is to use personal environment fit theory to design an algorithm that will rely on a very limited set of highly relevant variables. So therefore, this is the research question. To what extent and parsimony can job ads be matched to job seekers' needs for flexible working without direct measures of perceived fit or advertised perceived flexibility? Okay, so we want parsimony and we want to avoid direct measurement. So this is how I intend to use person environment fit theories to answer the research question and the industry problem. So I start from this diagram, you're probably aware of it, distinguishing between objective supply and needs, subjective supply and needs, and perceived fit. So it starts from, I would say, perceived fit. So perceived fit is this sense of fit that individual experience. So this is the key in this project because we want job seekers to feel this sense of fit. So we don't want to construct some statistical construct of fit. We want this construct of fit to be experienced by the individual. So this is why the final outcome of this project is to predict this Moller approach, this perceived fit. So now the way this perceived fit is evaluated uh, is mostly based on supplies and needs as perceived by the individuals. So I know there is debate around this, especially in the Edwards and colleagues 2006 papers, linking these two maybe different constructs together. But anyway, that's the model I would like to test and use. So distinguishing subjective supply, subjective needs. So what is present in the environment and what the individual needs as perceived by the individual. This is driven by objective supplies and needs. So these are supplies that are actually present in the environment, and objective needs are what the individual actually needs, even if the individual doesn't know about it. So that's the starting point. And that's the way this model is translated into this research problem. So in this research project, perceived fit is the job seeker's perception that the advertised job may provide enough flexibility. So that's the feeling we want to predict. We want to predict the extent to which a certain job ad will be experienced as a fit by job seekers in order to suggest them relevant job ads. So about the subjective supplies and needs. The subjective supplies are the flexibility that is perceived by the job seeker in the job ad. So it is not the flexibility of the job itself, because the job seeker does not have the full picture of the job. The job seeker only has the full picture of the job ad. So the job seeker can only know about the flexibility that is advertised in order to make informed judgments. So that is the supplies in the context of this project. And the subjective flexibility needs is the minimal flexibility that the job seeker would like to accept. Now, needs here in this project is a minimal state rather than an ideal state. Why? Because if I were to measure an ideal state, I would have job seekers wanting a lot of flexibility, perhaps even more than what they would be willing to accept. So the point of fit may not be relevant in my situation. Some individuals may accept a job uh, or apply to a job even if this job is not ideal. It has to be above the minimum, though, but it might not be ideal. So this is why needs are measured as a minimal state rather than an ideal state. Now, remember a problem for this algorithm. We cannot ask participants questions about subjective supplies because they haven't read the job ads yet. So they cannot answer questions about it. So we need to predict these subjective supplies in some ways. So for this, we use the objective flexibility supplies. So this is the flexibility that is actually advertised in the job. So it might derive from the content of the job ad. Keywords such as teleworking, part-time job, flexibility, etc. So the job ad is containing certain keywords that are what the flexibility is of this job ad, the advertised flexibility. And finally, objective flexibility needs. So this I would not assess in this project, but this might be the minimal flexibility that the job seeker can reasonably accept because of several reasons, such as disability or having to take care of children at home or large commute time, etc. So this is the minimal flexibility that the individual can accept, regardless if this individual is aware of it or not. So as I said, the first hypothesis would be to predict perceived fit based on subjective supplies, subjective needs. So this is the prerequisite condition, because if this hypothesis does not work, I cannot go further in developing this algorithm. So we need to be able to predict perceived fit with the needs and the supplies as perceived by the individual. The second hypothesis is to avoid this direct measurement of supplies that we cannot do. So the second hypothesis is trying to predict subjective supplies from objective supplies. So in other words, the project for this hypothesis is to be able to predict supplies, flexibility supplies, as perceived by the individual from the actual contents of the job ad, such as the keywords, the title, etc. So we will use the actual content of the job ad to try to predict the subjective flexibility supplies as perceived by the individual. Second hypothesis. And finally, the third hypothesis is combining the previous two. So this would be about being able to predict the sense of fit based on the objective supplies. So this is the content of the job ad, the actual content, and subjective flexibility needs. So this is the needs as stated by the individual. Now this hypothesis will answer the research question, because we can ask the job seekers about the flexibility they need before, when they register on the website, for instance. And then if this hypothesis is supported, we will be able to predict perceived fit with the content of the job ad combined to this preliminary questionnaire. So the research question and the industry problem will be solved because we'll be able to predict fit without direct measures related to specific job ads. So this is how I intend to do it. The methodology will be using machine learning linear regressions. So I'm not using linear regressions done in a statistical package because this is not useful for the company. Because if I use a statistical package, then the company would need to run the regressions, save the coefficients, then use these coefficients to develop this algorithm that will do the matching on their website. And if they want to update or refresh the coefficients, they will have to run the statistics again, etc. So this is not very feasible. So I'm using a machine learning implementation of linear regression. So the advantage of the machine learning technique is that the coefficients of the linear regression can adjust in real time to the new collection of data. So when individuals register on the website, they answer this questionnaire, then they read job ads and they say whether it is fitting their needs or not. And the computer can run a new regression and update the coefficients and use these new coefficients for the other predictions. So this is why I use machine learning. It's, I would say, like just the same as doing linear regression, but with two advantages. One advantage is that the coefficients are refreshed on the collection of new data. And the second advantage is that this algorithm, machine learning, is easier to integrate in a website because there are already libraries that can be used in websites. So it will be based on two algorithms. One algorithm will predict subjective supplies from the content of the job ads. So this was hypothesis 2. And the second algorithm will predict the sense of fit from the content of the job ads and the needs of the job seekers. So this is research question 3. Now the sample individuals who took part in the pilot study to develop the algorithm are volunteer users of this website. I've got 93 users who analyzed a set of 410 job ads. So what they did is answer a first questionnaire about their needs, flexibility needs, and then they were confronted to a series of job ads they had to read and then they had to answer questions about these job ads. For instance, perceived fit. So they had to read the job ads and determine whether this job ad was providing them enough flexibility. And they had also to answer question about subjective supplies. So they had to state the extent to which the job ad was advertising flexibility. So I asked them about this question because this is how machine learning operates, and actually this is how linear regressions operate as well. Because I've got the outcome variables, I've got the independent variables, so I can use them to form the initial coefficients that will be used to create the algorithm. Because the algorithm cannot do the prediction if we don't know at the beginning uh, what this algorithm has to predict. So we use these questions that individual answers to train the algorithm. Okay, so we tell the algorithm, like a child, we tell the algorithm, here is the perceived fit, and here is the needs of the individual, and here are the content of the job ad, or etc. I want you to predict perceived fit from these inputs. And then the algorithm will learn from these inputs outputs and be able to predict perceived fit by itself, okay, without having to collect the data. So that is how it is used. And this is a summary of the different algorithms. So as I said, first algorithm predicting supplies from the content of the job ad, and second algorithm predicting the sense of fit from flexibility supplies and flexibility needs. Once the algorithm has been developed, we need to integrate it in the website and then test whether the algorithm is useful. And I will do this with an experiment. So in this experiment, I will integrate the algorithm in the website, and I will invite users to test the algorithm and to be suggested relevant offers. But actually, they will be allocated randomly to one of these three groups. So one control group that will see random job ads, so job ads that have not been matched by the algorithm. Another group that will see low match, so job ads that have been matched by the algorithm as a low perceived fit, or the high match groups. So these will be individuals who will see job ads that have been matched to their needs. And then I will compare the scores on perceived flexibility fit of these three groups. Hopefully, the individuals who have been allocated to the iMatch group will experience much bigger sense of fit. So this will prove that the algorithm works and that the algorithm is capable of predicting perceived fit from the content of the job ad and the needs of the individual. So I don't have an algorithm to show you at this stage, but I do have some linear regressions result I can show you. So these were done in the SPSS statistical package. So remember, this is just normal linear regression. They will later needs to be adapted to a machine learning linear regression, as I said. But these results are quite promising, at least for hypothesis one. So remember hypothesis one, I wanted to predict perceived fit from the subjective supplies and the subjective needs. Now, if you look at the R square, because that's one of the only thing I care about is this project, is the predictive power of my algorithm. This algorithm needs to be able to predict fit in a reliable way. So this project is about the R square and the parsimony in the amount of inputs. So the first step is the control variables. So you see between 2 and 3% of perceived fit are predicted by the control variables. The second step is what interests me the most. So in the second step, I've got the subjective flexibility needs and the subjective flexibility supplies. And here the R square jumps to 70%, 71%. So 71% of this sense of fit is predicted by subjective supplies and demands. So I would say this is much higher than the previously reported links between the Muller and the atomistic approach. For instance, in Edwards and colleagues 2006, I think the maximum was about 58%. So now I've got 71% of perceived fit predicted by subjective supplies and needs. So this means then just with these questions, the minimal flexibility that individuals would like to accept and the extent to which they perceived a job ad to advertise some flexibility, with these two things, I'm able at 71% chance to predict the sense that the job ad is corresponding to their needs for flexibility. So this is for random, completely random job ads. So the job ads that individuals saw for this pilot study were completely random. So for instance, you might have someone wanting to work in human resources, and this person saw random job ads from accounting or marketing or some other job. So they saw random job ads. And still, with random job ads, you can predict this sense of fit at a 71% chance. Now, if I add, I would say as a control or something, the perceived demands ability fit as a proxy of the extent to which the job is relevant to the individual, okay, if the job is corresponding to their skills, this jumps at 72, 73% prediction. So I would say this is quite promising. So this is not the algorithm yet, but it shows promises, at least for hypothesis one, because it shows that I might be able to predict perceived fit from the supplies and needs. So finally, very briefly, here are some potential implications. Of course, there are some practical implications because the company would use the algorithm for its business. So it will be useful to this company in particular. It might be useful for other companies as well because this algorithm will be documented. I will try to publish papers out of it, etc. So it can be eventually replicated for other companies or for companies that would like to use person environment fit to do matching algorithm, even if these algorithms are not related to flexibility. Could be algorithm to match individuals, CVs, to keywords from the job ads, or it could be other types of person environment fit. From a theoretical perspective, hopefully it will be a better understanding of the links between the atomistic and the molar approaches, so the links between perceived fit and actual fit. Hopefully a new method to assess fit that could be highly relevant to industry. So this machine learning methods to predict perceived fit from the actual content of the job ad. So this could be interesting from a research perspective as well. And in addition, more understanding of the links between objective supplies and subjective supplies. So how do people form a sense of perceived supplies from the reality, I would say, or from the content of the job ads in this project? So here are some of the implications. So if you want to stay in touch, if you want to continue learning about this project, I invite you to visit my website, jfstitch.com, and hopefully I will try to post some updates on this project, or you can contact me as well, we can discuss. So thank you for your attention, and I'm looking forward to hearing your comments and suggestions.